We're all constantly looking for the best something, right? The best route to work, the best investment, the best design. Well, that whole search is the core of what we call optimization. Today, we're going to dive into a really fascinating paper that imagines this search as a kind of digital gold rush, and it shows how a team of virtual prospectors learned how to learn on the job, which, as you'll see, changed everything. Okay, so look at this. Imagine you're dropped right in the middle of this huge, foggy landscape, and your job is to find the single highest point in the entire range. Where do you even begin? Do you just pick the nearest big mountain and start climbing, hoping for the best? Or do you wander around for a while trying to get a lay of the land first? This, right here, is the exact dilemma that every single optimization algorithm has to deal with. And that brings us to a fundamental trade-off, this constant tug of war that's at the heart of any search problem. It's the battle between exploration and exploitation. Here's an easy way to think about it. Exploration is all about searching far and wide, covering a ton of ground to maybe find a whole new mountain range you didn't even know was there. But then you've got exploitation. That's when you find a spot that looks promising and you decide to dig in deep, spending all your energy climbing that one peak. Now, if you explore too much, you'll wander forever and never actually reach a summit. But if you exploit too much, you could spend all your time on a tiny hill, completely missing the massive mountain right next door. So finding that sweet spot, that perfect balance, is everything. You need a strategy that knows when it's time to wander and when it's time to dig. And this is exactly what a special class of smart algorithms is built for. They're basically the high-tech treasure maps for our digital gold miners. So let's start with the original map that our prospectors were using. It's an algorithm with a pretty perfect name, the Gold Rush Optimizer, or GRO for short. Now, GRO is really interesting because it's inspired by how real gold prospectors acted during the gold rushes. It sends out a whole team of digital search agents, our prospectors, into the landscape to find the gold, which for us is the best possible solution. And to do this, they have three main strategies in their playbook. So what's their game plan? Well, it boils down to three key moves that are meant to balance that big trade-off we talked about: migration, collaboration, and panning. Let's see how they're supposed to strike it rich. First up, we've got migration. This one's pretty intuitive. As soon as one prospector finds a really good spot, yells "Eureka," the other prospectors tend to move towards that location. It's a really powerful way to get the entire group to zero in on a promising area of the map. Next is collaboration. Now, this isn't just about blindly following the leader. Here, the prospectors actually share information. One might basically say, "Hey, I found something kind of interesting halfway between where I am and where you are." This lets them explore totally new directions based on what the whole group knows, which keeps everyone from just piling up in the exact same spot. And finally, there's panning. Once a prospector is in a spot that feels promising, they stop wandering all over the place and they start digging. This is our exploitation move, a super careful, focused, local search to see if they can find an even better speck of gold right where they're standing. So, migration, collaboration, panning. Sounds like a pretty solid plan, right? You've got a good mix of exploring and digging. But there is a huge critical flaw in how these old-school prospectors were designed to work. Here it is. They never learn. In the original GRO algorithm, each prospector just randomly picks one of those three strategies every single time they make a move. They don't remember if migration worked really well a minute ago, or if panning is a better bet in this part of the map. They are literally just guessing, rolling the dice and hoping they pick the right move at the right time. And this is where the paper introduces a simple, but honestly brilliant fix. The researchers asked, what if the prospectors could learn? So let's meet the new and improved team, the Adaptive Gold Rush Optimizer, or AGRO. So what is the fundamental difference here? Well, if the original GRO was using a fixed, old-timey map, AGRO gives each prospector a smart compass. It has a learning mechanism built right in. If a strategy, let's say it's collaboration, leads a prospector to a better spot, that strategy gets rewarded. It gets points. And over time, the strategies that are actually successful are chosen way more often. The algorithm literally adapts to the landscape it's in. The paper puts it perfectly. This new adaptive mechanism is the game changer. It's actively prioritizing whatever is working right now, which makes the whole search process way more dynamic and intelligent. And you know what? This learning ability wasn't the only upgrade. AGRO got a complete overhaul. For instance, its panning phase is now much smarter. It actually focuses its local search based on how promising the area is. They also fixed a subtle math bug that was sometimes pulling prospectors in a weird direction, making the whole search much more fair and unbiased. So, the theory is fantastic, right? A prospector that learns should absolutely beat one that's just guessing. But did it actually pay off? Let's look at the results. And here is the proof. On these graphs, just think of it this way. The lower the line goes, the more gold they've found. The red line is our new AGR algorithm, and the blue one is the old GRO. And just look at that. Whether it's a simple landscape or a really complex one, that red line just plummets. AGR finds better solutions, and it finds them way faster with a lot less wasted effort. The takeaway here is undeniable. Just by adding a simple mechanism to learn from what works, the algorithm is completely transformed. It stops wasting time on moves that aren't working, and it doubles down on the ones that are. It just becomes a much, much more effective treasure hunter. Okay, so we've built a better digital gold prospector. That's cool, but why does this actually matter to us? Well, the real treasure here isn't digital gold. It's what these kinds of algorithms can help us solve in the real world. These smart search methods are the engines running behind the scenes on some of our most complex problems. They're used in engineering to design more efficient cars, in logistics to find the fastest delivery routes for packages, in finance to build smarter investment models, and yeah, even in training artificial intelligence. Better algorithms mean better solutions to the problems that affect all of us. And that brings us to a final pretty powerful thought. The shift from GRO to AGRO is really a shift from a static, dumb tool to a learning, adaptive one. And it really makes you wonder, doesn't it? What other massive challenges could we solve if all of our problem-solving tools were smart enough to learn and adapt on the fly?